Good morning, Algebra 2. We are going to be covering Lesson 102, which is solving log equations and inequalities. So at the top, I put kind of a little review. Remember that a logarithm is the inverse of an exponential. So when I write log base 3 of 9 equals 2, the reason I write it that way is because 3 squared equals 9. But when we write it as a logarithm, I switch the 9 and the 2. So this section is broken up into parts, and so I'm going to start with how to solve equations where I only have one log, and so I'm going to start here. So I'm going to do a couple examples with you. So if I have log base 5 of x plus 2 equals 3, and we are solving for x. And so let's go over the parts. If I'm going to write this in exponential form, I start with my base, then my exponent, then the answer. So I start with base, exponent, answer. So to solve this, I'm going to rewrite this to be 5, and then the 3 equals x plus 2. And when you rewrite it like that, look how easy this problem becomes, right? Log is gone. Now I just have 5 cubed, which is 125, equals x plus 2. Subtract 2, right? And x equals 123. Okay, so let's try another one. And again, remember, always feel free. You can pause the video and try it. I am going to make each of these a little bit harder. So this next one, we're going to solve log base 8 of x cubed equals 2. So remember, when you rewrite this, go base, you're going counterclockwise, base, exponent, answer. So if you want to pause the video and try rewriting that. So base, exponent, answer. So now I have the 8 squared equals x cubed. 8 squared is 64. Now you can do this two ways, okay? One way is to then take the cube root. And so here I get x. And then on my calculator, I'd enter 3, and then I have this x root. So I'm telling it take the cube root of 64. And so x equals 4. All right, so let's dive into our lesson practice. I don't have the page number written down, and I apologize, but part A, solve log base 3 of x minus 1 equals 2. All right, so to solve this, we're going to rewrite it base, exponent, answer. So base, exponent equals my answer. So I get 9 is equal to x minus 1. And so what number take away 1 equals 9? The answer would be 10. Part B, so log of 125 x cubed equals 4. So let's rewrite this. Base, exponent, answer. So my base is 125. Exponent equals my answer. So I'm going to use my calculator. 125 to the 4th, I have to look that up. It's a very, very large number, right? So I get 244140625. 244 million equals x cubed. And then I'm going to take the cube root. So using my calculator, 3 cube root of second answer. And I get that x equals 625. Okay. So that is the first part. When we have one log, we solve by writing it in exponential form. Now we're going to solve where I have multiple logs. So this time I'm going to have more than one log. So for example, log base 2 of x plus log base 2 of x minus 3 equals 2. All right, now notice I have more than one logarithm. So I'm using the product property of logarithms, and that product property states that when I have two logarithms separated by addition, I find the product of the two pieces. So I'm actually going to multiply x times x minus 3 and then equals squared. Notice now I only have one logarithm, right? I only have one log. So I'm going to go ahead and distribute. So x squared minus 3x equals 2. And now I'm going to rewrite it, right? I have a base, exponent, answer. So 2 squared equals x squared minus 3x. So I'm going to shift over here. So 4 equals x squared minus 3x. Now I'm going to factor this, so I'm going to subtract the 4. So x squared minus 3x minus 4. That's negative 4, negative 3. So my factors are negative 4 and positive 1. So x minus 4, x plus 1. So I have two possible solutions, 4 and negative 1. Now, really quick note, I cannot take the log, cannot take the log of a negative number. So this is extraneous. I don't know if you remember that word. So the only solution is x equals 4. All right, next one. We're going to do kind of 2 in 1. So the next one we do is both going to have more than one logarithm, but also an inequality. So a log of 12x minus log of 4 is less than the log of 25. So I'm going to use the quotient property because I have a subtraction sign. And the quotient property states that if I have subtraction, that I will divide 12x by 4. So I'm dividing by my two pieces. So I'm dividing. And now I have less than log of 25. Now what I've learned is that if both logarithms on each side of your equal sign or inequality have the same base, then the log base 10 cancels. And I'm left with, 12x divided by 4, right, would be 3x is less than 25. So log base 10 cancels. And then I would divide by 3. So x is, all the values for x that are less than 25 over 3 are a solution. So let's go back to our lesson practice, and we're going to work on parts C, D, and E. So part C. If I have the log of x plus the log of x plus 9 equals 1. Okay, so for this one, because I have a plus sign, I'm using the product property. So I have log of x times x plus 9 equals 1. And then I'm going to distribute, so log of x squared plus 9x equals 1. Now the next part is really important. Notice I now only have one logarithm, but you've got to be able to identify that if they don't write the base, it's an invisible 10. So I'm going to rewrite this number. Base, exponent, answer. So 10 to the first power equals x squared plus 9x. Now I'm going to end up factoring them. So I'm going to subtract the 10. So x squared plus 9x minus 10. So I've got a negative 10 and a positive 9. So positive 10 and negative 1. So my factors are x plus 10 and x minus 1. So x equals a negative 10 and a positive 1. But remember, I cannot take the log of a negative number. So my only solution is x equals 1. So you're only circling that which works. Part D, solve the log of 45x minus the log of 3 is greater than or equal to 1. All right, so in this case, I'm using the quotient property. So the log of, because of the subtraction sign. Also, I remember that the quotient has a bar, and so does the subtraction. So I remember that they go together because they look alike. Divided by 3 is greater than or equal to 1. So I'm going to simplify this. This is the log of now 15x is greater than or equal to 1. And I'm going to fill in my invisible base. Now I don't have a log on both sides. I just have one log. So remember, we go base, exponent, answer. So 10 to the first is greater than or equal to 15x. So I'm going to divide by 15. And I get x is equal to x is less than or equal to 2/5 because I switched how I wrote it. Last one. Log of x minus the log of 2 equals the log of 75. So again, on the left, I can use the quotient property. Log of x over 2 equals the log of 75. Now I know since they didn't write a log, I have an invisible base 10. So because I have two logarithms, one on each side of the equal sign, and they both are the same, then x divided by 2 must equal 75. So what number divided by 2 equals 75? X equals 150. For your homework, for this section, so for homework 102, we're going to skip numbers 7 through 9, 13 through 15, and 18. Thank you very much.